So now if we go back to this little thing that I had right here, I want you to look at how closely related finding slope from 2 points and finding slope from a graph is. Because you know what we do with 2 points? We put them on a graph and we make a line. Kate, you need to move if that light is right in your eyes. So here's my 2 points. Here's what it looks like on a graph. So if I keep going with the whole change in y divided by change in x business, let's look at my y-axis. Where is this point on the y-axis? It's not 20, it's at 8. And where is this point on the y-axis? And guess what? To get from 8 to 16, I'm doing it again. I'm either doing it in a table, as an equation, or now from 8 to 16. That's the distance that I went up. Now let's look at the change in our y values, or x values, sorry. I went from an x value of 9 all the way over to an x value of 20. Do you see your subtraction problem on the graph right now? So guess what? Let's go back to this. And this is slope from 2 points. And I really wish I would have saved some space here because this is what I want you to write next. I know Mr. Meeks probably gave you, when you're on a graph, this formula is going to change again. It used to be delta y over delta x. I expanded it into y2 minus y1 over x2 minus x1. I'm going to change it again. Because on a graph, you know what we call slope? Anybody remember? I know you're going to remember when I tell you. Rise over run. Oh, that's the actual definition of slope. It's the rise over the run, which is the x on the bottom and the y on the top. It's the y divided by the x. It's the change. It's the shifting. It's the vertical shift divided by the horizontal shift. So while finding slope from 2 points is helpful, it's kind of a lot of work. It's kind of a pain in the butt. So I want you to take out this sheet right here that you already have all your positives, negatives, zeros, and undefined on. And I want you to take a look at number 1. So here's how I start with slope on a graph. I say, pretend like this little graph is a city. It's a map. You're zooming in it from the top. And all these little grid lines are streets. And you live in this house right here. And how do you read a line? The same way you read a book, from left to right. So the point that you're going to put your pencil on first every single time is going to be the point that's farthest to the left. That's your house. You're going to get on your bike and you're going to ride to your friend's house. Where does your friend live if each of these is streets? They live 1 street up and 2 streets over. So if the definition of slope on a graph, I want you to write these words, rise over run, then what's my rise and what's my run? And this is where maybe if you have 2 different colors, it could come in handy. I'm going to rise 1. I'm going to run 2. So if I have to put the rise over the run, and my rise is 1, and my run is 2, what's my slope? I have. Hey, you want to know something cool? Keep going. Keep going up 1 and over 2. Up 1, right 2. Up 1, right 2. What happens every time? Do you land on the line? Yeah. Up 1. Ooh, there's another spot. Hey, from here, let's not go up and right. Let's go down 1, left 2. Down 1, left 2. It's a constant up 1 over 2. So, guess what we're going to do with rise? I need you to understand that rise is not only an up movement, rise can also be a down movement, which really sounds kind of weird because when you think rise, you think everything goes up. That balloon was rising. So let's say you get in an elevator, and instead of the buttons that say what floor you want to go to, what if they had buttons that you had to push that were labeled how many floors you want to go up or down? So let's say you're on the 10th floor, and you want to go up 5 floors to the 15th floor. You don't push 15th floor. You have to push 5. You have to put plus 5. If you're on the 10th floor and you need to get down to the 6th floor, what button do you push? -4, right? So you're actually rising a negative amount? Yes. So if I'm at 10 and I need to go 4 floors down and the button 6 isn't there, but the button -4 is, right? So guess what? When your rise is going down, it's what kind of a number? Negative. So let's take a look at number 2. I already have an n there, so I know this is a negative slope. So guess what? When you put your m equals, there had better be a negative number there, because it's a negative slope. And here you go, left to right, there's your house. This time your friend doesn't live up and right. They live where? Down and right. So my rise this time is what? Not 2, but -2. And what's my run? +2. Well, that brings up a good point. If my rise is -2 and my run is +2, Mrs. E always wants us to reduce our fractions when possible. My slope is really what? Is -2 over +2 going to be on the answer key? No, but what is? -1 is. 2 divided by 2 is not 0. Okay? Yes. You will not get it wrong if you do not reduce. But that might be something that prevents you from getting a 4 if you have all unreduced answers and I'm asking you to reduce, okay? So -2 divided by +2 is -1. Okay, let's look at 5. Well, kind of funny, because 5 is already done for us. Guess what? You don't have to do any calculations, because when you have one of those special case lines, you know the slope of a horizontal line is what? 0. It's already there. But watch. I'm going to prove to you that it's 0. Where do you live? Right here. What's your rise? 0. What's your run? 1. What did I say when 0 is in the numerator? So 0 over 1 is 0. Your friend lives on the same street as you. You don't have to go up or down to get to their house. They're right next door. Does that make sense? So your rise is 0, your run is 1. I don't care what your run is. Guess what? Your run could be -6, because 0 over anything is 0. Are you with me? That means for number 8, what are we going to talk about then? It's kind of weird, because when I say find the point farthest to the left, which one's farthest to the left? There isn't one, so I don't care which one you pick. It's not going to matter. Let's just start here. What's my rise? -2. What's my run? 0. And what did I say when 0 is under? It's undefined. And doesn't that prove true, because isn't the slope of a vertical line undefined? Do you see how it's all tying together? Special cases will haunt you if you don't get them straight now. Okay? So let's take a look at number 6. I already know that it's going to be positive because it's going up from left to right. So whatever number you put on this line better not have a negative in it, because it's not. So let's start here. What's my rise? I'm going up 4. And what's my run? I only went over 1. So if my rise is 4 and my run is 1, my slope is really 4. If you leave it as 4 over 1, you won't get it wrong. You just won't see it like that a lot, right? Okay, I want you to try number 4. So your rise is a downward movement, and you went down 5, and you went right. And by the way, you know you don't start counting that point. This next one is the first one. So that's 1, 2, 3, 4. So your slope is -5 over 4. Hey, and you know what? Sometimes it just doesn't reduce. Reduce it when you can. If it's a mixed number, don't make it improper. Or if it's improper, sorry, don't make it a mixed number, okay? So here's the deal. I have kids sometimes say, oops, and they start at this point. I want to show you that even if you start at this point, it works out to be the same thing. Because let's say you start here and you go up and left. What's your rise this time? 5. This time, what's your run? You're going to the left. And what does a leftward movement on a coordinate plane mean? Negative. So this time you have 5 over -4, which worked just like we flip-flop the points. You can go either way. My advice to you, to keep it simple, is every single time you run, try to run right. Okay? So let's flip it over on the back. And holy smokes, what are we missing? What's not there? Points. So guess what? If the points aren't there, you got to make your own. But you can't just pick any old point. You're looking for an intersection of grid lines. So if I zoom in really, really close on this one, do I want to put a point right here? Nope. Maybe right here looks good. And then this next part is questionable. It's keep scrolling down the line until you get to a point. Does that even look like it goes? No. Keep going. That looks like it misses it. Keep going. But that one looks pretty darn good, right? So there's going to be a little bit of a pre-work that you have to do before you can find the slope. You got to plot the points first, okay? And so now, once you have your points there, then you can find your rise and then your run. So go ahead and try that and go from there. So your rise is 8 and your run is 3. And it's supposed to be positive. Okay? Does this make sense?